Hi everyone, my name is Gideon Grader. I'm a professor of chemical engineering, and I'm going to talk to you about the development of a new hydrogen generating technology from Technion, and that led to a startup company called H2 Pro. So H2 Pro was started by my partner Avner Rothschild from the material science department, myself, and two former students, I would say. Hen Dotan, who is here in the picture on the left, who is now CTO in the company, and Avigai Landman, who was a joint student of Avner and myself, who is now also working for the company. And what you can see here on the right side is a nice picture from early on in the company when we rented space at the Technion hydrogen lab. And we were there for about half a year. So why is hydrogen so interesting? You could see here the global market for hydrogen. It's about 75 million tons of hydrogen are made annually. The total market size is about $150 billion a year. And today, all that hydrogen, I would say more than 99% of that hydrogen is made by SMR from natural gas. It leads to about 10 tons of CO2 for every ton of hydrogen that is being made. And it also contributes between 2 and 3% of the global air. You could see that today we pretty much grow by a factor of 10. It's going to be for the renewable sources. Analysis, hydrogen and oxygen, this means that for the membrane compartment, this rate penalty. And so this overpotential run hot at the current two compartments. Okay, a swing here in this process. In addition to much simpler, step one, we the current off. So anode, okay, so it contains hydrogen. When we exchange the electrolyte, imagine that we have many cells. These sometimes makes hydrogen, some cells. Okay, what we call the balance of plant. You see them here at the very left corner. We have three reservoirs: a hot reservoir, a cold reservoir, and another reservoir, in the intermediate one that I don't have time to speak about. And by clever valving before and after the cells, we could switch the flow of the hot and cold electrolytes. And you would think that, okay, because we are switching between a cold phase and a hot phase, we have to spend more energy on reheating and recooling the electrodes. And the answer to that is that, no, this is not going to happen in a real system, because the regeneration reaction is exothermic. In other words, the oxygen release reaction is exothermic. The hydrogen reaction is endothermic. And consequently, if you design the electrode correctly, you can work without spending electrical energy on heating or cooling. Okay, so this work was published in Nature Energy in about 2 years ago. And in addition, we entered it into the Shell New Energy Challenge competition. This happened last year. And we won. Okay, we took first place in this competition. So the game for H2 Pro now is scale up. Okay, and you could see here a progression of scaling up that we're now doing. This is the first machine that we built about a little short under 2 years ago. It only made 10 grams a day of hydrogen, but it did it automatically. And it had a very small area that you could see here, about 200 square centimeters of electrode area. The next one was 10-fold larger. It's a 100 grams a day system. You could see that the electrode size is increasing to about 0.5 meter square. The next one is a system that we're commissioning these days. Okay, it makes 1 kilo a day. It already has about 5 meters squared of electrodes. And then the next system is a 10 kilo a day system that you could see here. It's currently under construction. And the next two systems is 100 kilo a day and a 500 kilo a day system, which would be already at the commercial level. And I would mention that this 500 kilo a day system, which is due, we plan it for the end of next year, December 2022, is a 1 megawatt system. So in order to do that, before that, you could see here a summary of all the systems and where we are. And yeah, we expect to get to a commercial system by the end of next year. So to make all of this happen, what you can see here is that we need electrodes. Okay, and what you see in this picture is what we call a mini line. Okay, this is already a step up from where we started, making electrodes that are about 50 centimeters long. We take these electrodes and we roll them. Okay, and what you see here is the basic rolled electrode. It has the anode, the cathode. It has a screen in between just to prevent a short circuit. But this is what we load into our reactors. Clearly, this system is not sufficient. We're now already building a larger coating line, an automatic coating line. Here, the electrodes are going to be 2 meters long. And we have started to design the commercial production line, which is going to be 8 meters long. In addition, we have a lot of other R&D activity to improve the quality of the electrodes and to check their stability. So far, we have reached 50,000 cycles and about 5,000 hours. And we plan to get to on the order of 100,000 cycles testing and showing that there is no degradation in the electrode in that time frame. So last slide, something about the financing. So our company raised about $30 million so far. We started with strategic partners like Hyundai, who supported our seed round, and then Sumitomo, who came in the next round. And then the last round, which was completed a couple of months ago, was led by Breakthrough Energy. This is a VC, okay, that was started by Bill Gates and Mike Bloomberg and Joe Bezos. And it's probably one of the better VCs that we have come across, okay? And yeah, they led the investment and we're very happy to have them on board. They're helping us a lot. Other two companies that joined this round were Bazan, it's the local northern refinery in Israel, and NFE, which is an energy company in the United States. So last slide. I've shown that hydrogen is a huge market, okay, today. It's going to get a lot bigger in the future. We have a breakthrough technology. We believe that we have a strong IP, and we're making it even stronger. The technology is significant in terms of its efficiency and in terms of the cost of goods at the end, that we believe will be very competitive with the existing market. Finally, we have a very strong team, and I would like to add that all of this started here at Technion as part of the Technion Energy Program. And with this, I'd like to thank everyone for listening. Thank you.
Hi, Gideon. Nice to see you. Thank you for this brilliant presentation. That was very interesting. So we have, Gideon, one question from the audience today. Maybe you already answered this one, but let's ask anyway. Can we say that this hydrogen is clean and that the electricity used for this technology that you just presented produces no CO2 or less CO2 than usual? Can you answer that?
Yes, yes, of course. The machine that we invented, yes, the process we invented, it by itself does not care where the electrons come from. Okay, it is completely transparent to where the electricity comes from, so it can come from renewable sources or non-renewable sources. But of course, for the hydrogen to be called green, the electricity should come from renewable sources, like from solar electricity or from hydropower or from wind power. Anything that is a renewable source generating the electrons would contribute to the formation of green hydrogen. So yes, they definitely, if the renewable electricity is used for making the hydrogen, it would be green hydrogen, and of course much cleaner than how hydrogen is currently made.
And much cheaper as well, you said.
Well, yes, because today the cheapest electricity that we could buy is solar electricity, right? I mean, it's PV. It's already at about incredible, about 1 cent per kilowatt hour at some places. And it may even get lower than that. And this is, of course, the cheapest electricity that we could buy today. But the problem is that it is, of course, intermittent, right? It's when the sun is on. So it's a few hours a day. And so we need to develop storage. And hydrogen, or taking water and splitting them and making hydrogen, is a form of energy storage. So yes, the way that we have devised to make it is cheaper. And of course, this is only one side of the coin. The other side of the coin is how to utilize that hydrogen. And that is with the fuel cells, which are still not at a very high efficiency. Still, nevertheless, fuel cells are much more efficient than the internal combustion engines. So yeah, there's still a way to go.
Very interesting. Thank you, Gideon. So we wish you good luck for the H2 Pro startup. Thank you very much for being with us today. And we see you soon. Bye, Gideon.
Yeah.
Bye.
And Valerie, I want to thank you very much for this opportunity, and to thank all the audience. And yeah, to wish everyone good days, and we'll talk soon. Bye-bye.
Thank you, Gideon. Bye.
Bye.
Take
Bye.
care.